All right, geometry. Welcome back to lesson 9-5, the Pythagorean theorem. To start off, we have a picture of Pythagoras. 500 BC is when he lived. He was a mathematician and a philosopher, and he contributed a lot to Greek society of the time. But this is the theorem that is attributed to his name. We're going to talk about that today. So beginning with, what is a right triangle? Something to remember, we talked about this before, talked about types of triangles. So specifically, a right triangle is a triangle that has an angle that is 90 degrees. Okay, so a triangle that has an angle which is 90 degrees is a right triangle, right? It's named by its angle, just like an obtuse triangle has an angle over 90, and an acute triangle has all angles less than 90, those kind of ideas. But yeah, it's a triangle which has an angle that is 90 degrees. It also has two legs, or two sides that make up the right triangle, and they're called legs. Okay, so each of those is a ray of our right angle. And the side opposite the right angle is called the hypotenuse. Okay, so always the side opposite is the hypotenuse. Again, remember when I say opposite, I mean if I'm standing at the right angle looking at the interior of the triangle, I'm going to be looking at that side. Okay, so same thing as what we've been talking about with opposites, as we've been defining what that means in geometry and those kind of ideas. The Pythagorean theorem specifically comes to us from Theorem 52. In a right triangle, the square of the hypotenuse is equal to the sum of each of the legs squared. Okay, so that's where we get that a squared plus b squared equals c squared format. You can kind of read this as well as like a problem we might see in algebra, where they give us the word sum, which means we need to add. Equal to, obviously we know that one. The square means I'm going to be taking a quantity and squaring it. Those kind of ideas. We can read this theorem and determine that it's going to be a squared plus b squared equals c squared, a and b representing each of those legs. There's a note here for us. The hypotenuse c is always the longest side and opposite the right angle. We can think about why that is, maybe, given a right triangle. Our triangle angle sum is always going to be 180, right, in Euclidean geometry. So if we have a right angle, the largest any of these other angles can be is 89.9 repeating degrees. And that would mean this angle is going to be something much less, right? Like 0.00001 degrees. But still, this angle is going to be less than my 90-degree angle here. We always talked about those, or we have talked about those triangle inequalities that talk about my longest side always opposite my largest angle, and my smallest side or my shortest side is always opposite my smallest angle. Those ideas. So that's where that comes from. We call that the hypotenuse. So taking a look at this and visualizing it again, A is going to be my one of my legs, B is the other. It doesn't really matter which one you choose to be A and B, as long as you're choosing C to be that hypotenuse, right? So C is going to have his own side of the equal sign. A and B's sum is on the other side. So let's go ahead and do some practice. It says find the length of the hypotenuse. Okay, so we don't know our C. That's what we're trying to find, looks like. So we'll go ahead and take 12 squared plus 16 squared equals C squared. That's how we're going to set that up. Again, coming from that form of A squared plus B squared, those being the two legs, equals my hypotenuse squared. All right, so 12 squared is going to give me 144. 16 squared is going to give me 256 equals C squared. When I add those together, I'm going to have 400 and equals C squared. And then again, to solve these, this is why we worked those square roots previously. We're going to take the square root of either side. a square and a square root cancel. They're inverse operations, right? Just like multiplication and division, so they cancel. C is equal to plus or minus 20, right? Whenever we take a square root, it's always going to be plus or minus a number. And then I ask myself, is it possible for C to be a negative value? Is that even possible? Can a length be negative? We say no. So we're just going to go ahead and make that a positive 20. So making sure I ask myself those questions. Does this make sense? Is this a possible value for the answer I'm getting? Looking at the problem in context, all good things to do that I hope we're practicing as we practice these. Same thing here again. They've given us both of our legs, 5 and 7, and they're asking us to find our C, our hypotenuse. We can say a squared plus b squared equals c squared, and then go ahead and solve. So 5 squared, or insert your values, I should say. 5 squared plus 7 squared equals c squared. 5 squared being 25, 7 squared being 49, and c squared just being c squared. 25 and 49 is going to give me 74 equals c squared. Okay. Then, again, I want to take the square root to get rid of my square, right? Those are inverse operations again. Same thing on my 74. So I'll have c is equal to the square root of 74. Okay. 74. Once I'm done with that, I need to think, okay, are there any factors of 74 which can help me solve this? Okay, so 74, does 4 go into that well, right? Because I got to think of my perfect square factors, 1, 4, 9, 16, 25, 36. I remember also one of those rules I talked to you about where I said the largest factor of this number can be is half the size, right? So 36 is going to be my biggest possible value. So you can even take out your calculator and divide those. And if I don't get a nice whole number, those aren't going to work. So 36 is out, 25 is out, 16 is out, 9 is out, 4, we can try that one. 74 divided by 4 gives me 18 and a half, so he's out. And 1, again, wouldn't change that. So my final answer here is going to be square root of 74 units, or just square root of 74. Okay, so when I'm doing these hypotenuse questions, I do want your answer in simplest radical form, which happens to be square root of 74 here. I do want your answer in simplest radical form. Here they didn't give us a picture. They just said that the length of the, find length of the hypotenuse given that the legs of a right triangle are 6 and 8. So I'm going to go ahead and draw my own picture. Maybe extend this side a little bit. And call this one 6 feet. This one 8 feet. And I'm going to go ahead and try and solve for my C, my hypotenuse. So 6 squared plus 8 squared equals C squared. I have 36 and 64 equals C squared. 36 and 64 when added together give me 100. And then when I take the square to both sides, that's going to be one of my nice perfect squares. So C is going to be equal to 10 feet. Well, I said units, 10 feet, right? Because they gave us the units that time. C is 10 feet. So we got 6, 8, and 4. Another thing to notice as we talk about this is the Pythagorean theorem only works in a right triangle, okay? So I'm glad they told us that qualifier, that's a right triangle. Let's check all the rest of these. Oh, right angle, good. Right angle, good. Right angle. All these are right triangles. So make sure you're not using the Pythagorean theorem on things that are not right triangles. So again, this one's a right triangle. I got my right angle. And I'll go ahead, and it's a closed three-sided shape, so it's a right triangle. I'll go ahead and solve for this one as well. So I'm given 4, which is a leg, but then I'm giving 10. Remember, 10 is opposite that right angle, meaning that's the hypotenuse. And then I have x centimeters. I can call that b, maybe. B centimeters. So I'm unsure what my other leg is, okay? It says find the length of the missing leg. So So I'm going to go ahead and write down 4 squared plus unknown value b squared equals 10 squared. Oops, 10 squared. Okay, so now I'm going to have simplify my squares on the integers. 4 squared plus b squared equals 10 squared, which is 100. And then I'm going to go ahead and combine my like terms across equal sign, which means I need to do the opposite operation. So minus 16, 100 minus 16 gives me 84 equals b squared. And then I take the square roots of both of those sides. And I get b is equal to the square root of 84. And then I ask myself, can that be simplified any further is the big question, right? I'm gonna write down my perfect squares: 1, 4, 9, 16, 25, 36, 7 is 49. Okay, so 49 is over half, I think, of 84. Yep, so 49 is gonna be out. Wait, 36 is gonna be out, I can just tell. 25 is gonna be out as well. You know, 25, 50, 75, 100. I could try 84 over 16. That's out. 84 over 9. That's out. 84 over 4 I have a good feeling about, though. It's going to give me 4 and 21. Okay, so I'm going to want to rewrite this as the square root of 4 times 21, and then I can mark that I'm taking the square root of 4. When the square root of 4 comes out, he's going to be a 2 root 21. That's what I'm looking for, 2 root 21. Then I ask myself, does 21 have any factors here besides 1? No, it does not. So my final answer for that leg there is 2 root 21 centimeters. Okay, find the length of the missing leg here. This one we can call A maybe, since it's on the left, inches. It doesn't matter how you label it, though, as long as it's a variable, right? Go ahead and set up my equation. A squared plus 12 squared, those are my 2 legs, equals my hypotenuse squared, which is 13. Okay, and now I'm going to simplify. So a squared plus 144 equals 169. And I'm going to combine my like terms across the equal sign. So minus 144 is 25. A squared equals 25. Take the square root of both sides. I know that 25 is a perfect square. That's going to give me 5 for that value, and my label is inches, 5 inches for that value. All right, find the length of the missing side of a right triangle if a leg is 4 feet and the hypotenuse is 8. All right, so let's label our one leg 4 feet, our hypotenuse 8 feet, and go ahead and begin, right? So we are missing our A value or a B value, just missing a leg, right? One of the 2 legs. We know that it's also right triangle, which is important because that means we can use the Pythagorean theorem. So let's go ahead and set this up. 4 squared plus A squared. Doesn't matter the order of these 2 because we should remember that addition is commutative, equals 8 squared. So I'm going to have 64 on this side, 16 on this side, and an a squared in the middle. Combining like terms across the equal sign, I'm going to subtract 16, and I'm going to get 48 equals a squared. And I'm going to take the square root of both sides. So I have a is equal to the square root of 48. And then I think, okay, not done yet. I got to double check to see if this is fully simplified. 25, that's going to be too big. 25 times 2 gives me 50. 16 is the next one to try, and 16 and 3 do give me 48, so I can write my current 48 as a product of 16 and 3. Take the square root of 16, and I'll have 4 on the outside, root 3. Again, that 4 is coming from taking the square root of 16, and my label is feet, or root 3 feet. Lastly, just a discussion of why does the Pythagorean theorem work in a right triangle. This is a nice visualization, like a visual proof almost, of why this works. So the area of each square, if we kind of take a look at our picture here, C is the length of that hypotenuse. We can notice that C is 1, 2, 3, 4, 5 blocks long, and also 1, 2, 3, 4, 5 blocks tall. Okay, so really I have a square here. Square should make you think of the squared part of that. I have a square here, a two-dimensional shape, that's 5 by 5, so my area would be 25. Okay, 25 units squared. Then taking a look at my A side, I have a block that's 1, 2, 3 long and 1, 2, 3 wide. So my total area for the A block would be 9 units squared. And then taking a look at my B block, I have a block that is 1, 2, 3, 4 blocks long by 1, 2, 3, 4 blocks wide, which is going to give me an area of 16 units squared. Okay, so if I'm also looking at this in terms of my Pythagorean theorem equation, this area of the one leg squared, if I square the leg, make it into an actual square, right? That's kind of what that means. And add that to the square of the A leg, I'll have 16 plus 9 equals 25, because they should equal the area of the block represented by the side C. And that's a true statement, right? 16 plus 9 is equal to 25. So this is kind of a good visualization of why this works. What does the square have to do with anything? Hopefully that clears up some of those questions for you. Okay, so that's kind of the big idea here. We got 25, 9, and 16. My two legs add up to the sum total of my hypotenuse value area, which is 25. Okay, so that is all we have for notes. Thank you for watching, and I hope homework goes well. I'll see you on Monday.